All right, so we set the realty example up in Excel like this, right? This might look slightly different than what I did in the last video, but it's about the same. Put in the parameters, and we got fractional answers, right? Is this okay? Was how we left off last time, and we said no, this is not okay. We cannot buy fractional townhouses. We cannot buy fractional apartment buildings. It has to be whole numbers. So now the question is, can we round the answers to get integer answers? So can we round those fractions to integers? If not, what else can we do? So let's go back. I'm going to do something crazy here. I'm going to take what we solved and I'm going to copy it, move it to the end, right? So this right here is the LP solution, and this is our rounding solution. So there are different ways to round this, right? So the first thing we have to do is when we round, we have to make sure we stay feasible, which means it meets all of the constraints at the same time. So right now, townhouse availability does not seem to be the binding constraint, right? We're doing 2.47, we have 5. What's binding us are these two, budget and time, all right? So what feasible solution would be, in this case, to round both of them down to the nearest integer, so a 2 and a 3. So let's do that. Here's a 2, and I'm just typing these in, right? 3. So now all of these meet the constraints. We get $65,000, right? And we are feasible. The question now becomes, are we optimal? Is this the best whole numbered solution, integer valued solution that we can come up with? Well, I don't know. So I'm going to do this again. I'm going to copy it, and I'm going to call this rounding solution 2. So last time I went down. Another thing we could do is say, well, this one's kind of close to 3. So let me put a 3 in there. I see I violated the constraints doing that, right? So that means I need to round this one down. Let's see if I can get a 3 in there and see what happens. No, 3 does not work. See, because budget 2046 is above my $2 million. So I would have to round this down to a 2, which would give me a 60. This is a 65. So two townhouses, 3 apartment buildings is better than 3 townhouses, 2 apartment buildings. So again, here we're feasible. Smaller objective function value. Here we are feasible. Larger objective function value. 65. We are how far away? What is that? 8.5 away. So we don't know. The problem with rounding is we do not know if the solution that we found by rounding is the best optimal integer solution. So we know that the first one is better than the second one, but we don't know if it's the best overall. So how do we guarantee that we get the best integer solution? Well, we have to explicitly put in integer constraints on the variables into the solver. So what that means is I would go back to the formulation. I would say that T and A each have to be integer, and then we'll have to figure out how to change that in the solver dialog. So we'll do that in the next video to see how good we are.